Hey guys, today we'll be doing a question from the 2014 Special Exam 2. This is question 2 from that paper, from the extended response section, and we'll be doing part C, or at least the modified version of part C. One that I've sort of modified so that year 11s can also give this one a go. As you can see here, I've drawn the circle, so this is a complex planes question. But I've drawn the circle for you guys, so you don't need any knowledge about complex planes in order to attempt this question. Yeah, but it's a really good one, and hopefully you guys have given it a shot already, so let's go through this one together now. First of all, what we're asked to do is we're given these 2 points, so k minus 2i and negative 2 plus ki, and we're told k is less than 0. So this is going to be important later. And we're also told that when we join these 2 points, right, these 2 points which correspond to complex numbers, when we join these 2 points, it will make a line that will be tangent to this curve. So it's a circle, this circle right here, okay? And we're asked to find the value of k. All right, so let's first let's try and do this question, but let's first try and figure out how we can place these 2 points. Okay, um, what we'll start with is this point here. This point here, minus 2 plus ki. So if I was to just expand this, I'm gonna get you know minus 2 minus k times I, right? Minus 2 minus k, and we're told k is a negative number, right? So this point lies on the y-axis, right? Because there's only an imaginary part, there's no real part, so it has to lie on the y-axis. And let's see where I can place it, right? So obviously I can't place it anywhere inside the circle, right? Because that doesn't make sense. It needs to be tangent, right? So it makes sense for me to probably place it somewhere above or somewhere below. Okay. And another thing, right? Since we're told k is less than 0, let's just pick a random value. Let's pick a value like, k is equal to negative 3, for example. If k was negative 3, then I'll get minus 2 minus 3i, and that's going to give me minus 2 plus 3i, or I guess minus 2i plus 3i, which is I, right? So we see that k not only has to be not only has to be less than 0, but it also needs to be less than a certain other number, right? In this case, k needs to actually be less than negative 2. And the reason for that is, if I was to place, k equals negative 2, if k was a negative 2, then I'd end up doing, minus 2 plus 2i, so minus 2i plus 2i, which is going to get me 0, right? And I can't have 0. I can't have something just lying on the top of the circle. It needs to be tangent. So the line joining the points needs to be tangent. So we figure out that k also needs to be less than minus 2. It's not really that important to solving this question, but just something interesting that I found. Anyways, so we'll place it somewhere here, I guess. The point. Let's just say it's somewhere there. So the next thing we know is next thing we can do is we can plot this point in k minus 2i. K minus 2i, so minus 2i is down here, and k should be somewhere around here, I guess. So yeah, I guess you can place it somewhere there. Okay, and the next thing we'll do is I guess we'll sort of join this line. We'll just sort of join these 2 points together such that they'll be tangent, right? So that's somewhat right. Looks somewhat okay. So yeah, we have sort of a straight line connecting these 2 points, and it's sort of tangent at this area here, right? So I'll just sort of label them in right now. This point is minus 2 minus k I, and this point here is going to be k minus 2i, right? We can also use the coordinate system, but this is fine as well. Not too important to solve the question again. Anyways, let's try and solve this question now. There are two ways you can sort of do this question, and hopefully you'll be able to figure out one of the ways. One of the ways is just by using the discriminant. Okay, so the discriminant is the more obvious way, I would say. It's much more obvious to use the discriminant in order to solve this question, but let's try and see how that would work. Well, to use a discriminant, first of all, we need to find the equation of the line. So the equation of the line is, first of all, let's find the gradient of the line, right? So m would be y2 minus y1 on x2 minus x1, right? y2 is this, I guess we can call this point, we can call this y1, y2, call the other one y1, right? So I can say minus 2 minus k, so that's y2, minus y1, y1 in this case is minus 2, so minus 2 minus k minus 2 on x2 minus x1. Our x2 is 0, and our x1 is k, right? So x0 minus k. So I'm going to get minus 2 minus k plus 2, which just all over negative k, which just gives me negative k on negative k, which is just 1. Okay, so therefore this line has equation y is equal to x, and we have to take into account the y-intercept, plus minus 2 minus k. So that's our equation. Okay, cool. Looking at the circle, we can already sort of figure out what the equation of the circle is going to be. It's just a basic circle that's been translated 2 units down. So the equation of the circle is x squared plus y plus 2 squared. And what's the radius of the circle? The radius of the circle is just 2. It's equal to 2 squared. So this one is the line, and this one is the circle. So obviously to find the discriminant, we've got to sub in the line equation into the circle equation, right? And when I do that, I'm going to get x squared plus x minus 2 minus k plus 2 squared. So I'm just subbing that in for y. Whatever y was, I'm just subbing it for this y in here, is equal to 2 squared. Okay, so I'm going to get x squared plus minus 2 plus 2 goes to 0. X minus k squared is equal to 2 squared, which is just 4. Okay, and then just expanding everything, x squared plus x squared minus 2xk plus k squared is equal to 4. And then, just bringing everything to one side, I'm going to get 2x squared minus 2xk plus k squared minus 4, right? So I've got some, so when I, when I sort of, made these two equations equal to each other, or I guess when I, substituted one into the other, I've come out with this quadratic equation. So this quadratic equation, realistically, when I solve this quadratic equation, had, had I had like a proper value for k, like an actual numerical value, I would actually be able to find what this intersection point was. But in this case, this point here is a tangent point, right? So what that means is this line only touches this circle one time, which means that if I was to solve this quadratic equation with that whatever value that k was, whatever value k is, if I was to solve this quadratic equation, right, I would only expect to get one answer, which means we can take advantage of the fact that the discriminant, right? So the solution of this quadratic equation, if it only has one answer, that means the discriminant must equal 0, right? And just using the discriminant to sort of, simplify all this, I'm going to get minus 2k squared. So the formula for the discriminant, if you recall, is b squared minus 4ac. Minus 2k is our b term, so minus 2k squared. B squared minus 4 times a, which is 2, times c. The c term is the constant term, so in this case it's k squared minus 4. And that all equals to 0. So at this point you can probably just put this in the CAS to solve it, but if you want to keep going, we can. So what can we do? Minus 2k squared just gives me 4k squared. Minus 8 times k squared minus 4 is equal to 0. I guess I can sort of divide both sides by 4 at this point. So I'm going to get k squared minus 2 times k squared minus 4 is equal to 0. Then k squared minus 2k squared plus 8 is equal to 0. So I end up getting, from here I end up getting minus k squared plus 8 is equal to 0. Okay? Which means that k squared is equal to 8, and therefore k is equal to the square root of 8, or plus or minus square root of 8, which is 2 plus or minus 2 root 2. And if you recall, k is less than 0, therefore our answer for k is equal to negative 2 root 2. Okay, so I did mention that this is one of the ways to solve this question, and it's probably the more obvious way, right? As you can see, we've just used a discriminant, which is something you've learned quite a bit through year 10, year 11, and year 12. You've used it quite a bit, right? And we do end up with the right answer here. But there is another way to do this just by using geometry. And if you have a good understanding of geometry and the circle theorems, you'd probably be able to answer this question much easier and with much less working out. And I'll quickly show you how that works as well. So just going back to the diagram we have here, right? Obviously our center point here is that if I just label this using coordinate form, or I guess, yeah, so our center point is at 0, -2, right? That's where the circle center is at, okay? You'll notice that since, I mean, we found the gradient of this line, right? So we know that this line has a gradient of 1, right? Notice that these 3 points sort of make a triangle with one another. So I can sort of draw a triangle here, okay? So I can draw a triangle with those 3 points. And because of the fact that this straight line here has a gradient of 1, I know that this angle here is 45 degrees, right? And I know that angle, which means that this angle here must also be 45 degrees, and obviously this one's 90 degrees. Okay, so interestingly enough, it's not this triangle itself that's helpful in solving this problem. It's another triangle. If you recall your circle theorems, if I was to join this point of tangency, I also join it up with the center of the circle, we'd know that whatever triangle, so this smaller triangle that's made here, the bottom here, right? This smaller triangle that's made, we know that the tangent line, if a line was to be drawn from the center of the circle to its circumference, and then there's a tangent line going through that point, we know that that point is also a right angle. So the tangent line and the line from the center to the circumference makes a right angle with one another. So that's one of the circle theorems you would have learned in year 10, year 11, year 12. Okay, so that's 45 degrees, that's 90 degrees, right? So we can just use some basic trig ratios. And I guess how can we sort of apply this? How can we apply these trig ratios to find k? Well, first of all, we know what this side is, right? This side has length 2 because 2 is the radius of the circle. And we also know what this length here is in terms of k at least, right? Because this length here, k is our x coordinate. If you think about it, k is our x coordinate and minus 2i is our y coordinate, right? So this length here itself, obviously it's a negative number, right? K is a negative number, but this length here itself, that length there is equal to the absolute value of k, right? If you're just talking in absolute terms, if you're just talking in terms of distance, then that length there is the absolute value of k. Okay, so now just based off this angle here, we can use a sine ratio. So in this case, sine of 45 degrees is equal to the opposite side, which is this side here, 2, over the hypotenuse, which is this side here, this bottom bit here, which is the absolute value of k, right? Sine of 45 is root 2 on 2. I can cross multiply, so I'm going to get 4 is equal to root 2 times the absolute value of k. I can divide both sides by root 2, so 4 on root 2 is equal to the absolute value of k. And if I rationalize, I'm going to get 4 root 2 on 2, which is equal to 2 root 2. So I end up with the same answer. The absolute value of k is equal to 2 root 2. And since we're dealing in absolute terms, right, and since we know that k is less than 0, we know that k itself must be negative 2 root 2. Okay, and that's probably the easier method. If you were just good with your geometry, you would have been able to figure out this question much faster and get the full 3 marks of this question. But yeah, these are just two simple ways of doing what would have been a very difficult question. So I believe in this exam, only about 9% of students got this question, got the full 3 marks of this question, especially because, you know, obviously these exams are long and you don't have much time to sit around and just think about it. So just some very useful ideas that you can take away from this. First of all, what you can do is, you know, you should always usually follow your gut instinct. So your gut would have been used to use the discriminant, so you do that, right? Because it's very easy. And if there's no problems with that, you should always just do that. Yeah, there's no problems with discriminant, and you can see it's probably a very good way of solving it. From one of these, after you've sort of simplified it to this point here, you can probably just start, you know, you can probably put in the CAS and get a good answer from it and get the answer straight away from it. But yeah, these are just two very simple methods of, or I guess two very simple, but you know, a method that you probably wouldn't have thought of straight away in the exam. So, but they're good methods for solving a problem like this. Hope this was helpful, guys. Hope you guys had a chance to try it out. Let me know if you guys have any questions in class. Okay, thank you. See you guys in class.